Hello everyone and welcome to my project presentation. Today I'm going to walk you through my application, the CO2 Emission Predictor. My name is Hrithik Manikandan and I'm the developer of this tool. In this video, I'll go through the app user manual, app development toolkit, and the final user interface. Here's a quick overview of what we'll be covering in this presentation. We'll start with acknowledgements to the people and platforms that helped me along the way. Then I'll introduce myself and share a bit about my background. After that, I'll take you through my internship journey with Clever, where I learned the skills to build this app. We'll then dive into the app itself, what it is, why I built it, and how it works. I'll show you exactly how to use it, then we'll explore each major feature in detail. Finally, I'll share my contact information in case you have questions or suggestions, and we'll wrap up with a thank you note. Before anything else, I want to take a moment to express my gratitude. First and foremost, I'd like to thank my parents for their constant encouragement and support. They've always motivated me to explore my interests and push my boundaries. A big thank you to my mentor, Abhishek Das, who guided me through the technical and conceptual challenges of this project. I also like to acknowledge Mr. Ken for his time. To my group members and my friends, thank you for your collaboration, for brainstorming with me, and for helping me refine my ideas. The Cloud platform also deserves special mention for providing an internship program that gave me both structure and freedom to learn. Lastly, I must thank you the countless online resources, articles, and documentation that made it possible to learn new techniques and solve my problems along the way. So let me introduce myself. My name is Hrithik Manikandan, and I'm currently a year 12 student with a strong passion for data science, machine learning, and software development and finance. I've also been fascinated by how technology can be applied to address real world issues, especially environmental challenges. When the opportunity came to join this internship, I saw it as the perfect way to bridge the gap between my theoretical knowledge and my practical application. A few things about me: I'm enthusiastic about using technology for social good. I enjoy exploring new innovations in AI, and I'm aiming to continue my education and career fields like AI, data analytics, or environmental technology. This CO2 emission predictor project is a step in that direction, a tool that reflects my commitment to using AI for meaningful, impactful insights. Now, let's talk about my internship experience with Clever. Over the course of this program, I've developed a variety of skills that went into building this project. I started with learning the fundamentals of AI, specifically neural networks and how LSTM models are uniquely suited for predicting time series data like CO2 emissions over the years. Next, I worked with real-world data sets. I learned how to pre-process them, fitting in missing values, cleaning data, and normalizing it for better model performance. From there, I built and trained an LSTM model to predict future CO2 emissions using data from 1960 to 2018. I then moved into app development, creating a user-friendly interface with Takinter so that anyone can select a country, pick a target year, and see predictions instantly. I also focus on data visualization, plotting emission trends with Matplotlib, and generating interactive world heat maps with Plotly. Along the way, I had to solve practical challenges such as ensuring proper input validation and making the UI as intuitive as possible. By the end of this journey, not only had my technical skills grown, but so had my confidence delivering a complete end-to-end AI solution. The CO2 emission predictor app is designed to be a powerful yet simple tool for understanding and forecasting carbon emissions worldwide. So here's what it can do. You can choose any country from our drop-down menu and see its historical CO2 emission data. You can select a target year between 2019 and 2050, and the app will predict emissions for that year using an AI model trained and historical trends from 1960 to 2018. The prediction isn't just a number, it's backed by accuracy metrics like mean absolute error, root mean square error, and the R squared score, so you know how reliable the model's output is. You also get visualizations, line graphs that combine historical and forecasted data, an interactive heat map showing CO2 emissions across the globe in 2018, and detailed insights for any selected country, including its highest and lowest emission years and patterns over time. This app takes complex climate data and makes it accessible, understandable, and actionable. Using the CO2 emission predictor is straightforward. First, open the application on your computer. On the main screen, select a country from the drop-down and label Select Country. Then choose a target year between 2019 and 2050 from the Select Year dropdown. Click the Predict button and the AI model will process the data to display the predicted emissions for that year. A separate window will open showing a graph with historical emissions from 1960 to 2018, plus the predicted values for future years. You'll also see the accuracy metrics displayed alongside the graph. If you want a broader view, click Show World Heat Map to see emissions for all countries in 2018, or Show Country Insights for more detailed stats and trends about your selected country. Just remember, predictions are based on past trends. Unexpected changes in policy, economy, or natural events can affect actual future emissions. The first major feature is the Predict CO2 emission function. Here's how it works. Select your country and target year from the drop-downs, then click Predict. The app will output the predicted CO2 emission value, show accuracy metrics, and generate a plot combining historical forecasted data. Visually, on the side, you can see the home screen on the left and the result screen on the right, with an arrow showing the flow from action to result. A couple of things to keep in mind. The prediction model uses historical data, so it may not capture sudden policy changes, economic events, or disasters. Also, the app checks that your selected year is after 2018. This ensures you're predicting into the future, not the past. The second feature is the Show World Heat Map option. On the main screen, click this button and you'll get an interactive map where each country is colored according to its CO2 emissions in 2018. On the slide, you can see a screenshot of the heat map result. It's important to note that this data is fixed, it's historical, not predictive. So it's mainly for comparison and visualization purposes. It's a great way to quickly understand which countries are leading or lagging in emissions for that year. The third feature is the Show Country Insights option. Here you select a country, click the button, and you'll see detailed statistics like the highest and lowest emission years, the average growth rate, and the largest single year changes. You also get a clear graph showing the country's emission trend from 1960 to 2018. Again, this is based on historical data, so any missing values have been handled internally by the app. This feature is particularly useful if you're analyzing long-term patterns or studying the effects of specific historical events on emissions. Now that you've seen the presentation, let's move on to the AI Development Toolkit workbook. This document essentially serves as the blueprint and record of how my CO2 emission predictor app was designed, built, and tested. It's divided into 4 key sections: project requirements, the user interface design, the event handlers matrix, and finally, the test plan. On the first page, you can see a complete list of the project requirements that I defined before starting development. Every single one of these has been implemented successfully, and you notice the completed column marked yes for all features. Data loading and pre-processing. The app loads historical CO2 emissions data from a CSV file containing country-wise annual emissions from 1960 to 2018. I implemented pre-processing steps to handle missing values, clean the data, and prepare it for the AI model. Country drop-down menu. This allows users to dynamically choose from all available countries in the dataset. The list is generated automatically from the data file, so it stays accurate if the dataset changes. Year drop-down menu. Users can select a prediction year between 2019 and 2050. This ensures you're predicting only future emissions. LSTM model for prediction. The heart of the app is an LSTM long short-term memory neural network model, which is especially good for time series forecasting like this. Prediction output metrics. When a prediction is made, the app displays not just the value, but also key accuracy metrics like MAE, RMSE, and R-squared. Interactive line graph. Historical and predicted emissions are plotted together so users can visually compare trends. Global heat map. A static visualization of CO2 emissions for the year 2018, created with Plotly for an interactive map view. Country insights. A detailed breakdown of emissions per country, including the highest and lowest years, and average growth and yearly changes. Error handling. Informative pop-up messages ensure that invalid inputs don't break the app and that users get clear feedback. Clean UI. The app interface is built in Tkinter, making it responsive, intuitive, and easy to use. This list ensures that I stay focused and didn't miss any core features during development. Here we have a visual layout of the app's interface shown through 5 screenshots that cover the main user journey. Initial view. This is how the app looks right after launch. After input selection, once the country and year are chosen. Prediction result. After clicking the predict button, a new window shows the emission prediction, accuracy metrics, and the plot. Heat map view. After clicking the Show World Heat Map button, the app displays an interactive global emissions map for 2018. Country Insights view. After clicking Show Country Insights, you get a detailed breakdown of that country's emission history and trends. These can help anyone understand the app's workflow without needing to run it first. This section describes how each interactive element in the app responds to user actions. Country dropdown. When a country is selected, it's stored for the upcoming prediction. Year dropdown. Same idea, the target year is stored. Prediction button runs the AI model and shows the results in a new window with the prediction, metrics, and trend graph. Show heat map button loads the world CO2 heat map for 2018 in the main window. Show insights button opens a window with detailed statistics and a historical trend graph for the selected country. This metrics is very useful for debugging and future development because it documents exactly what heat control does. Finally, this is the test plan, proof that the app works as intended. Each feature was tested step by step, including normal and error cases. For example, the predict button works as expected when valid inputs are given. Drop-down menus populate correctly from the dataset. The heat map loads without issues. Missing inputs trigger a warning pop-up. Trying to predict for a year before 2018 shows an error message instead of crashing. Every single test passed, meaning the app is stable, reliable, and user-friendly. So in summary, this workbook shows that the CO2 emission predictor wasn't just built randomly. It was carefully planned, designed, implemented, and tested to make sure every feature works exactly as intended. Next, I switch over to the live application so you can see it in action. So this is the initial page for my CO2 emission prediction tool. From this dropdown, you can select any country you want for the prediction. For example, Afghanistan. And from this dropdown, you can select the year you want the prediction for. For example, 2027. Then when you press the predict button, a new window opens up to show the predicted emission for Afghanistan in 2027, along with the accuracies for the result. It also opens up a graph for the historical emission, forecast start, and the prediction for 2027. Then you can press the Show Country Insights to see the insights for country Afghanistan. For example, highest emission, lowest emission, and the average growth per year. It also produces the emissions trend graph. Then when you press the Show World Heat Map button, you can see a heat map being produced in the same page for the entire world, along with the country with the highest emission, which is Qatar, in 2018. If you have any questions, feedback, or suggestions for improving the CO2 emission predictor, feel free to reach out to me. You can email me at vmhrithik@gmail.com. Thank you for your time and attention. I hope this video has given you a clear understanding of what my app does and how it can be used to explore and predict CO2 emissions worldwide.